Hello friends, welcome to the video lecture series of partial differentiation. In this video lecture, we are going to discuss some MCQs on partial derivative using Jacobian. So some formula I am going to write. If f1 uvxy is the implicit function of uvxy, second function again implicit function of uvxy, means we have two pairs of the functions, and del u by del x, from these two equations I have to find. So what will be the formula? Del u by del x. See, how to remember the formula that I am going to tell you. Here there is a group of u and v and group of x and y. See, u comes under the group of uv and v comes under the group of uv. X comes under the group of xy and y comes under the group of xy. So I want del u by del x, partial derivative of u with respect to x, using from these two equations, and these two functions are implicit functions. So what is the formula? When you find partial derivative, the minus sign by default is there in the formula. Minus sign is there in the formula. So write down del f1 f2 divided by del xy, del f1 f2 by del uv, del f1 f2 by del uv. Once again I explain. The Jacobian I am going to write. The Jacobian of f1 f2 with respect to u and v, because in the numerator u we have the u comes under uv group, the uv by default you write. Now this is not the formula. Now I am going to make the formula. I am going to write the formula. In numerator's Jacobian, replace u by x. In numerator Jacobian, replace u by x. Del of xv. Del of xv. This can be written in terms of determinant also by definition of the Jacobian. Now, del u by del y, how do you write? Numerator Jacobian and denominator Jacobian. So del f1 f2, del f1 f2, how to prepare the formula I am going to tell you. In the numerator u is there, u comes under the group of uv, so I am writing here u and v. U, v. Just once you write it, you correct it now. Replace u by y in the numerator's Jacobian. This has become the formula. And this is Jacobian, and Jacobian you can write, because earlier lecture, in previous lecture we have written, we found the Jacobian of f1 f2 with respect to y and v is what? f1 del f1 by del y, del f1 by del v. Now row for f2, del f2 by del y and del f2 by del v. Is it? Now here this Jacobian, how to write? Del f1 by del u, del f1 by del v, del f2 by del u, second row for f2. Okay. If you look at it very carefully, the last column, in first and last column of the determinant, the last column is same. See, last column is other than first one, the columns are same. Now the next formula for partial derivative I am writing, del b by del x. What to do? f1 f2, numerator Jacobian, this is denominator Jacobian, f1 f2. In the numerators, in the derivative, in partial derivative, v is present. V comes under the group of uv. Write down uv here. Write down uv. uv I have written. And now let's correct the formula. Replace v by x in numerator's Jacobian. Replace v by x in numerator Jacobian. Now this has become the formula. So this can be written by definition of Jacobian Okay, del f1 by del u, del f1 by del x, del f2 by del u, and del f2 by del x. Here del f1 by del u, del f1 by del b, second row for f2, del b. Okay, by definition of the Jacobian I have written. Now, the all possible partial derivative you can write. Now, the formula for del y by del b. From here, formula for del y by del b will be what? f1, f2. Here f1, f2 I have written. Now, in the numerator, y is present. In numerator of the derivative, y is present. Y comes under the group of xy. So, I am writing here x, y. I am writing here y, x, y. Now, correct the formula. In numerator's Jacobian, replace y by b. Replace y by b. Now, this has become the formula. And by definition of the Jacobian, you can write minus is there, del f1 by del x, del f1 by del b, del f2 by del x, and del f2 by del b. Okay, previously we have done so. Determinant here, del f1 by del x, del f1 by del y, del f2 by del x, and del f2 by del y. This is denominator's job. Now, del y by del u, how do you find? Write down f1, f2 here. Then this numerator's variables, y comes under the group of xy. So here I am writing x, y, xy. Now, complete the formula. Replace y by u in numerator's Jacobian. Replace y by u in numerator's Jacobian. Now, this Jacobian can be written by definition. Determinant of del f1 by del x, del f1 by del u. Here del f1 by del x. Yep. Second row for f2. Del f2 by del y. Now, for three variables, similarly, you can prepare the formula for three variables also. Here, these three implicit functions are given: u, v, w, x, y, z. See, there is a group of u, v, w. U comes under the group of u, v, w. V comes under the group of u, v, w, and w comes under the group of u, v, w. And the group of x, y, z, in group of x, y, z, x comes under the group of x, y, z, y comes under the group of x, y, z, and z comes under the group of x, y, z. So this we are going to write now. Del u by del x, how to write? Del u by del x, write down f1, minus sign by default it is there, f1, f2, f3. This is numerator Jacobian, and denominator Jacobian, this divided by del f1, f2, f3. Okay. Now u is present in the numerator. U comes under the group of u, v, w. So write down u, v, w, u, v, and w. Now correct the formula. Replace u by x in numerator Jacobian. Replace u by x. Now this has become formula for del u by del x. Now del w by del y. Here is the denominator. This is numerator Jacobian divided by denominator Jacobian. f1, f2, f3. Here f1, f2, f3. Now w is present in the numerator. W comes under the group of u, v, w. So I am writing here u, v and w. Here u, v, w I have to write. But in numerator Jacobian, replace w by y. W by y. Now this has become the perfect formula for it. Now this can be written as minus of. By definition you can write it. Okay, by definition. And you know how to write it. First row for f1, del f1 by del u, del f1 by del v, this is u, del f1 by del w. Okay, we don't have sufficient space here. This in smaller font I am going to write f. This is the second row for f2. Third row for f3. Okay, third row for f3 like this. Here del f1 by del u, del f1 by del v, del f1 by del w. Second row for f2, u, f2v, f2w, and here f3u, f3v and f3w. Okay, so this is important for you, this one. And by definition, this can be written from this. Okay. Now, it's from this del b by del z I am going to write. How do you prepare a formula for del b by del z? It's f1, f2, f3 we have to write. Here in denominator Jacobian f1, f2, f3. This is numerator Jacobian. This is denominator Jacobian. Okay. And in the numerator, here in partial derivative, v is present. V comes under the group of u, v, w. So I am writing here u, v and w. U, v and w. Now I am going to correct it. In numerators Jacobian, replace v by z. Replace v by z. Okay. So in this way, you can prepare the formula for partial derivative using Jacobian. Okay. By definition, del f1 by del u, del f1 by del z, del f1 by del w. Yes, second row for f2 and third row for f3. Here again del f1 by del u, del f1 by del v, del f1 by del w. Same row for f2, same row for f3. Okay. Now del z by del u I want. Del z by del u, how do you find? This is numerator Jacobian, denominator Jacobian, f1, f2, f3. Here f1, f2, f3. Replace, and in the numerator z is present. Z comes under the group of x, y, z. Here I am writing x, y and z. X, y, z. Now I am going to correct the formula. Replace z by u in numerators Jacobian. Replace z by u. And del f1, f2, f3 by del x, y, u. Del f1, f2, f3 by del x, y, z. Okay, this can be written in terms of determinant also. So in this way, we can prepare the formula partial derivative using Jacobian, and in examination, the formula will be asked. Okay, this you may be given these two equations, and any one of this partial derivative you may be asked. These three equations you may be given, and any one of the possible derivative you may be asked in the examination. Now, the problems on this topic. Okay, problems on this. How to find partial derivative using Jacobian. How to find partial derivative using Jacobian. Here we have two functions, x equal to u square minus v square, y equal to ub. These functions may be explicit function or implicit function. Here x and y are explicit function of u and v. You may be given implicit function also. Now, what to do? This del u by del x I have to find. What to do? Here two equations are there, two functions are there. Let us denote first equation by f1 or x minus u square plus v square, you can write. Shift this right hand side term in the left hand side, and f2, what, y minus u into v. Okay. What I want to write, del u by del x I have to write the formula. By default minus sign is there. Numerator Jacobian divided by denominator Jacobian. Numerator Jacobian del f1 f2 here like this. Okay. Now I am going to prepare the formula. In numerator of the partial derivative, u is present. U comes under the group of uv, because here 2 by 2, x and y, u and v are there. U comes under the group of uv. So I am writing here u and v. Here u, v. And replace u by x in numerator's Jacobian. Now this has become the formula. Del f1 f2 by del xv. Now by definition, here we don't have sufficient space. Here I am writing the direct steps. Del f1 by del x is what? Derivative of f1 with respect to x, keeping other variable constant. Derivative of x with respect to x is 1. Derivative of this will be 0, derivative of this will be 0, because we are taking partial derivative with respect to x, keeping other variable constant. Del f1 by del v, derivative of this with respect to v is 2v. Now, for f2, del f2 by del x is 0, because x is absent here. Del f2 by del v, derivative with respect to v, derivative of y is 0 with respect to v, and derivative of uv with respect to v is minus u. Now, denominator Jacobian. Del f1 by del u is minus 2u. Del f1 by del v is 2v. Del f2 by del u is minus v, and del f2 by del v is minus u. Now solve this determinant. 2 by 2 determinant you can easily solve. 1 into minus u is minus u. Minus of 0. This divided by product of these two is 2u square, minus of product of these two is minus 2v square, means minus plus here u by 2u square plus 2v square. You can take 2 common in the denominator. So this is del u by del x, where two functions are given to you, where these two equations are given to you. As from this again, I am going to find out del v by del y. So how do you write the formula for del v by del y? Minus del f1 f2 numerator Jacobian divided by denominator Jacobian. Okay, v is present in the numerator of the partial derivative. V comes under the group of uv. uv I am writing, and replace v by y in numerator Jacobian. Replace v by y. Is it? Now by definition of the Jacobian, minus determinant divided by determinant. Now del f1 by del u, derivative of f1 with respect to u is minus 2u. Del f1 by del y is absent, derivative is 0. Del f2 by del u is what? Del f2 by del u is what? minus b. Del f2 by del y is what? 1. Now denominator. Del f1 by del u is minus 2u. Del f1 by del b is 2b. Del f2 by del u is minus b, and del f2 by del b is minus u. Okay. Here, as I told you, this last column, other than first one, okay? This last column is same. Now we are going to solve this determinant. Minus 2u minus of this will be 0 divided by 2u square minus plus, or you can write indirectly also like this. Now 2u divided by 2 times u square plus v square. The u gets cancelled. In this way, del b by del y we found. Now find del y by del b. How do you write? Formula for this: numerator Jacobian divided by denominator Jacobian, del f1 f2. Here I am writing Jacobian. Okay. In numerator y is present, y comes under the group of xy. So xy I am writing x and y. Here xy. Now correct the formula. Replace y by b in numerator Jacobian. Replace y by b in numerator Jacobian. Okay. Now minus of determinant divided by this determinant, del f1 by del x, derivative of f1 with respect to x is 1, del f1 by del b, derivative is 2b, del f2 by del x, del f2 by del x, x is efficient, del f2 by del b, derivative is minus u. Okay. Now the last column we say, here I have written directly. As it is, you can copy it. Now del f1 by del x is 1, and del f2 by del x is what? Del f2 by del x is what? 0. Is it? Minus what? Product of these two is minus u divided by, because product of these two is 0, minus u minus of 0 is u by minus u. It is equal to minus 1. Okay, minus 1 is the value of del y by del y. So in this way, you can find out partial derivative using Jacobian. One problem of this type may be asked in examination. Now the same problem. X equal to cos theta minus r sin theta, y equals sin theta plus or cos theta. This function may be implicit function also. So here we have the group of variables like this, see, xy and r theta. R comes under the group of r theta, theta comes under the group of r theta, x comes under the group of xy, and y comes under the group of xy, like that. Formula I am writing minus, Jacobian I am writing. It's 2 by 2 variable, f1, f2, only 2 equations are there. F1, F2. If 3 equations are there, F1, F2, F3, like that. This divided by F1, F2. This is denominator Jacobian. In numerator of the derivative, r is present. R comes under the group of r theta. Here r theta, r theta. Now I am going to correct the formula. How do you correct the formula? In numerator Jacobian, replace r by x. Replace r by x. Now this becomes the formula for partial derivative. Now minus determinant divided by determinant, directly writing del f1 by del x. What is f1, f2? That I have not written. Okay, here I am writing. f1 is what? r minus, shift right hand side on the left hand side. This I am shifting on the left hand side, r sin theta. And f2 is what? F2 is what? Shift right hand side element on the left hand side. Okay. Now del f1 by del x, derivative of f1 with respect to x, x is absent, is 0. Del f1 by del theta, derivative of f1 with respect to theta, derivative of r with respect to theta is 0. Derivative of this is what? Minus cos theta is sin theta. And derivative of sin theta is what? Cos theta. R is multiplicative constant. Now del f2 by del x, del f2 by del x, okay, del f2 by del x here. This should be x, this should be x. I have written here r, should be x. Okay. Now del f1 by del x, derivative of f1 with respect to numerator Jacobian and denominator Jacobian. Okay, this I am going to eliminate. Del f1 by del x is 1. Del f1 by del theta is what? Derivative of minus cos theta is sin theta. Derivative of sin is cos. Now derivative of f2 with respect to x is 0. Derivative of f2 with respect to theta is derivative of minus sin theta is cos theta with minus sin, and derivative of minus cos is plus sin, like that. Now del f1 by del x, the last column is same. This I am going to copy it. Okay, you have to have the practice of it, sin theta is the last column, and the first column del f1 by del r, derivative of f1 with respect to r, derivative of this is 0 with respect to r, derivative of this is 0 with respect to r, the derivative of this term with respect to r is what? Sin theta, because derivative of r is 1. Okay, sin theta I have put it. And derivative of f2 with respect to, derivative of f2 with respect to r is what? Minus cos theta. Is it? Now solve this determinant, numerator determinant and denominator determinant, and try to find out the value. Okay, this is for you. This is for you. Now del r by del theta I am going to find. Del r by del theta, how to write the formula for this? Minus del f1 f2, formula I am writing. Numerator Jacobian divided by denominator Jacobian. Is it? Now replace r by theta. This r is there in the numerator. R comes under r theta group. Replace r by theta in numerator Jacobian. Okay, del r by del theta we have defined. It should be what? Del r by del y. Del r by del y. And r is replaced by y here, like this. It should del r by del y. Now, how do you find out it? Minus numerator divided by denominator. Okay. Now derivative of f1 with respect to y is 0 because y is absent. Derivative of f1 with respect to theta is what? Minus cos theta, derivative is sin theta. And derivative of sin is cos. Derivative of f2 with respect to y is 1. Derivative of f2 with respect to theta is what? Minus sin theta. Derivative is cos theta. And derivative of minus cos theta is plus sin theta. Now denominator. Derivative of f1 with respect to r, this second column is always same, sin theta plus r cos theta minus cos theta. This is what? del f2 by del theta means minus cos theta, okay, plus r sin theta. Now del f1 by del f1 by del r is sin theta only here, and del f2 by del f2 by del r is minus cos theta. Okay, and you can solve the determinant. Okay, this is for you. In this way, del theta by del x you can find out del theta by del x. Okay, so only formula I am writing del f1 f2 this Jacobian divided by next Jacobian. Theta comes under the group of r theta, and replace theta by x in numerator Jacobian. Replace theta by x. Okay. Now try to find out, try to evaluate this. Okay. Now 3 by 3 variable problem. X equal to u plus v plus w, y equals u minus v plus w, and z equal to v plus w. Here, let us denote it by f1. F1 is what? X minus u minus v minus w. F2 is what? Y minus u plus v minus w. This I am shifting on the left hand side. And F3 is what? Z minus v minus w. Okay. Del u by del x I want. This 3 by 3 variable problem. Okay. Less likely to be asked in examination. But we are going to practice only single problem on 3 by 3. See, what is the formula for this? Del u by del x. Okay, here we have the group UVW and XYZ like that. Minus by default F1, F2, F3. Numerator Jacobian divided by denominator Jacobian okay. Now u comes under the group of UVW. I am writing here UVW and correct it now. Replace u by x. So now determinant divided by denominators determinant. Directly write del f1 by del x. Derivative of f1 with respect to x is 1. Derivative of f1 with respect to v is minus 1. Derivative of f1 with respect to w is minus 1. Derivative of f2 with respect to x is 0. Derivative of f2 with respect to v is 1. Derivative of f2 with respect to w is minus 1. Derivative of f3 with respect to x is 0. Derivative of f3 with respect to v is minus 1. Derivative of f3 with respect to w is minus 1. Now here, see f2v, f3w, f2v and f3w. Okay, other than this first column, these two columns will be same. I am going to write as it is. Or you can find it out by procedure minus 1 and minus 1 like that. Okay. Now here in this column what will happen? Del f1 by del u. What is derivative of f1 with respect to u is minus 1. Del f2 by del u. Del f2 by del u is minus 1. Del f3 by del u. Del f3 by del u is 0. Okay. Now try to solve these numerators and denominator Jacobian. If you try to simplify it, what will happen? See, 1. Okay, you can use calculator to get the value also. And the minor of 1 is what? Product of these two is minus 1, minus 1, minus 1 is minus 2 directly right. Okay, minus 1, minus of 1 is minus 2. Minus sign by default in the formula. Minor of minus 1, leave this column and row. Product of this 2 is 0, product of this 2 is 0. Minor of this minus 1, leave this column and row. Product of this 2 and product of this 2 is 0. Divided by here minus 1, multiplied by, what is the minor of minus 1? This minus 1, give this row and column, minus 1 minus of minus, which is minus 2. Second element, minor of minus 1, leave this column and row, 1 minus 0. Minor of this minus 1, leave this column and row, 1 minus 0 is 1. So what will happen here? Minus 2, and this minus is plus 2 divided by, here this is 2, this is 1, 3, 3 minus 1 is 2, and what is del u by del x? Del u by del x is what? 1. A 3 variable problem, less likely to be asked in examination. Only single problem for practice I take. Okay. Now the next part of the applications of partial differentiation or applications of Jacobian, you can say, that is functional dependence and independence. This functional dependence and independence, okay, minimum 2 problems will be there in the examination. See, what is mean by functional dependence? Two functions u and b are said to be functionally dependent if and only if Jacobian of u and b with respect to x and y, z. And you know how to find out the Jacobian. For 3 variables, 3 functions f1, u equal to this, v equal to this, and w equal to this. Here u, v, w are functions of x, y, z. There are 3 equations, 1, 2, 3. 3 by 3 variable problem are functionally dependent if and only del u, v, w by del x, y, z is 0. With this Jacobian equal to 0. And now, to much more practice we have taken how to find out the Jacobian, how to evaluate the Jacobian. Here one more note I have written: if functions are functionally dependent, then there is a relation between them. If 2 functions are functionally dependent, then there is a relation between them. Now, quickly, first problem: u and v are given to you. Are they functionally dependent? That you can check. Del uv by del xy is equal to 0, then they are functionally dependent. The relation is asked, therefore it is very clear that they are functionally dependent. Its Jacobian is 0, but that is not asked, only relation is asked. Now if you look at this function very carefully, tan inverse x plus tan inverse y equal to this, then we have formula, we have trigonometric formula. Tan inverse x plus y is equal to what? 1 minus xy equals, this is the trigonometric formula. This is the trigonometric formula we know. This formula we are using 11th to 12th standard also. Now, in this formula, tan inverse x plus tan inverse y is v, which is given. And here, in this problem, x plus y by 1 minus xy is u. Okay, therefore tan inverse u is equal to v is the relation, or u is equal to, shift tan inverse on the right hand side, it will be tan v. So this is the correct answer to this. Okay, u equal to tan v is the relation between u and v. Next problem, u equal to sin inverse x plus sin inverse y, then v equal to x root of 1 minus x square plus y root of 1 minus y square, y under root of 1 minus x square. Then the relation between u and v is asked. We are going to find out the relation. Okay, here what I am going to do, I am going to let sin inverse x equal to a and sin inverse y equal to b. For convenience I am going to let it. So x equal to sin a and y equal to sin b. Okay, now what is b given to you? B is given x under root of 1 minus y square and y under root of 1 minus x square. It is given to you. Now, if you put value of x, which is sin a, value of y, it is sin b, y square, sin square b, this is sin b y, and x square is what? Like this. Okay. Now, sin a, 1 minus sin square, under root of 1 minus sin square is what? Cos of b, sin b, and 1 minus sin square is cos under root. And sin a cos b plus sin b cos a, the trigonometric formula you have, sin a plus b. Okay, this is the formula we have. Now v is equal to sine of, and a plus b is what? A plus, this is a and this is b. Okay, a plus b. That a plus b is what? U. So b equal to sine u is a relation between this u and b. So when you find relation, then it should be free from xy. It should not, presence of x and y should not be there. Presence of x and y should not be there. See, if you look at this, the presence of x and y is not there. Now, check the functional dependence for all xy. Here the question is like this. We are going to check functional dependence. Relation is not asked. Whether they are functionally dependent or not, we are going to check del ub by del xy. This is Jacobian. If value of this is 0, then we can say u and v are functionally dependent. If it is not 0, then it will be functionally independent or functionally not dependent, you can say. Now by definition, how to write? Del u by del x, del u by del y, del v by del x, and del v by del y. Then this determinant, del u by del x is what? Derivative of u with respect to x. Del u by del y is what? Derivative of u with respect to y. Del v by del x is what? Cos of x plus y. And derivative of u with respect to y is what? Cos of x plus y. Okay. If you solve it further, cos x into cos of x plus y minus cos y into cos of x plus y. Okay. Now, cos x into cos of x plus y minus cos y into cos of x plus y. Okay, these two terms are not same. Okay, means if you take cos of x plus y common, suppose, so cos of x minus cos of y. Okay, so it is not going to become 0 for all xy. For all xy, it is not going to become 0. This Jacobian is not 0. Therefore, u and v are not functionally dependent. Not functionally dependent for all xy. For all xy. It may be the chance that for particular values of x and y may be 0. Now, see, we have here three variables: u, v, w, x, y, z. U, v, w, then relation amongst u, v, w is asked. Okay, relation is asked means they are functionally dependent. Means Jacobian is 0. But that we are not supposed to check here because only relation we are going to find. Yes, how to find out the relation amongst u, v, w? If you look at these three equations and if you look at x, y, z, here x, y, z terms are here x, y, z term, here also x, y, z term. But if you look at carefully, here there is each and every term is of degree 2. Each and every term of degree 2. Then each and every term of degree 1. Yes, we are going to simplify these three equations and we are going to remove x, y, z. So you can use your way to remove x, y, z. That's all. What I am going to do? So u is equal to x plus y plus z. Then I am making degree 2. So what I am going to do? X plus y plus z whole square. Now, x, a plus b plus c whole square means what? X square plus y square plus z square plus 2xy plus 2xz plus 2. Okay, the term of x has exhausted. Now this plus 2yz. Okay, we have expanded. U square is x square plus y square plus z square is what? P. This is equal to p plus 2 times 2 is common. 2 is common. So u square equal to v plus 2 times xy plus xz plus yz. Xy plus y x z plus yz is what? W. Means this can be replaced by w. This is the relation amongst UVW. Okay, this is the relation amongst UVW. Now the same problem, this one. UVW are given. Find relation amongst UVW. Find relation amongst UVW. So if you look at it very carefully again, this is the term on this right hand side. 2z square is there here like this. Okay. So we are going to solve these three equations and we are going to remove x, y, z. So you can use your way to remove for the removal of it. Okay. Now, what I am going to do? I am going to take square of it. That's why I am going to take square, because if you take square, the z square is there. This square of this y square is present, yes. And yz term, yes, yz term is also present. What I am going to do? Y plus z whole square. And let us check what you get. Y square plus 2yz plus z square. Okay. But after taking square of it, the terms gets repeated in remaining two equations or not, you can check. See, y square is present, yes, but minus 2 is there. Yz is present, yes, minus 2 times. And like this. Okay, what to do? I am going to multiply it by minus sign. Yes, I am going to do like this. Let us check what we get. Yes. Now x 2z square and minus of u square, I have written minus y square gets repeated. Okay, what I am going to do, if you multiply it by minus 2, what will happen? Please say what will happen. Minus 4z square. Okay. Now minus 2u square is equal to minus 2y square and minus 4. Okay, value of this is what? W minus 6, as I am writing here, W minus 6. Minus 2y square minus 4yz is W minus 6. Okay, that I have done. Minus 4z square I am writing as it is. Okay. Now, just you concentrate on V. If you concentrate on V, then what will happen? W minus x minus 2z square. Okay. So what? X plus 2z square. Okay, x plus 2, because minus 2, it's one more thing. Okay, how this 2 has come? See, 2 should not be there, you know. If you multiply it by 2, it should be 2 here. Now, it should be 2 here. Minus 2u square, w, take minus sign common, x plus 2z square. And minus 2u square equal to what? W minus x plus 2z square is v. Okay, this is the relation amongst u and w. Okay, you can multiply it by minus sign also. Okay, sometimes it becomes confusing. You know? Okay, here we have committed a mistake. Extra 2 I have written, that's why it was very difficult to get the equation, but that mistake we have identified and we solved it. Now, find relation between these two. Okay, so these problems are simple, you know, it is very clear. If you find value of x from equation, this equation and put it there, or x by x is 1 I am writing and y by x. Okay, but if you look at it very carefully, if you divide numerator and denominator by x, what will happen? Divide numerator by x and divide denominator by x. Okay. Now, u is equal to. So, what is value of y by x from this? Y by x equal to v minus 1. Put v minus y by x value here. Put y by x value here. Okay, 1 minus 1 cancel. This is 1 minus b plus 1 by b, 2 minus b by b. Okay, therefore, the relation is what? U into b is u into b is equal to 2 minus b. This is the relation amongst relation between u and t. Okay, so you can find relation by your way also. So you can do like this also. Find value of x from here and put it here, or find value of x from here and put it here. That way can be done. Now the same problem again. Here b is equal to xy by x minus y whole square, and u equals x plus y by x minus y. What I am going to do, I am going to, numerator, divide numerator by x, divide denominator by x, okay, and here also divide numerator by x square. If you divide numerator by x square, this will get, if you divide this by x square, 1 minus y by x whole square. This right hand side of this two I have brought in terms of y by x. So find value of y by x from here. U into 1, u into y by x. Okay, 1 plus y by x. Then shift y by x on the right hand side. Shift y by x on the right hand side, and 1 here. So u minus 1 is equal to y by x, 1 plus u, because y by x is common, and u minus 1 by u plus 1 is y by x. Okay, so putting value of y by x here now, so what will happen? Therefore v equals y by x, this is the value of y by x, divided by 1 minus y by x, 1 minus y by x, this bracket is what? Y by x. Now v is equal to u minus 1 by u plus 1, here u plus 1 is LCM, u plus 1 is LCM, then u plus 1 into 1 is u plus 1 minus u minus 1, like that. Okay. Here if you open the bracket, then minus u plus u gets cancelled. U minus 1 by u plus 1 is divided by, now minus 1 plus 1 is 2, 2 by u plus 1 whole square. Now v is equal to, this u plus 1 will jump in the numerator, u minus 1 by u plus 1. It will jump in the numerator, u plus 1 whole square by 4. Now 1 u plus 1 gets cancelled, u minus 1 into u plus 1 by 4, and v is equal to, therefore v equal to, product of this is what? U square minus 1, because a minus b into a plus b is a square minus b square, and divided by 4 I am shifting here on the left hand side. This is the relation between u and v. Okay, in this way, the relation between two variables, relation amongst 3 variables that we have found. So one problem of this type may be asked in the examination. Okay, for this topic we stop here. Thank you very much.